can see. Option B? B? Yes? Sure? He is saying the load balancer already in public subnet. His main concern is about that web servers and the databases. Sometime back, I shown this document, right? I told you something. I asked you to mention 8 subnets. 2 subnets is for public. There, your load balancer will run. 2 private subnets for web application. 2 private subnets for database. I already told this just some time back only. Now, what is your answer?
Yes, sir.
So, public. Your database is in public subnet. Is it okay? So your database contains a lot of sensitive information. So is it okay? No. Again, why C, sir? See, some time back only, I talked about this, right? I've shown this. Why not B? You see here, 2 public subnets is for load balancer. See, in this question also is mentioning same. He already have a public subnet and their load balancer is running. Do you need to worry about public subnet now? And he's saying fleet of EC2 instances that is running with auto scaling group. Where you want to keep that, and where do you want to keep this? RDS MySQL. So I can place my web servers here. I can place my database servers here. So I told you all are valid. You can create infrastructure with all the 4 options. But which one is more secure? That is matter. So, which one is secure? B is secure. Yes, sir. Okay. Database, we don't make public. Okay. So, go with the B as answer here. You got the logic? Yesterday, I have given a task. Where your web server is running, where your EC2 instance is running, private. Where your load balancer is running, public. And later I'm going to add a database. Where I'm going to add? In private only. So even if you apply the task here, you can give the answer. Correct? Yeah. Where is that? I think I have closed it module wise. APC. Okay. The question is very lengthy, but answer you can easily tell if you understood the logic. An application runs on EC2 instance in multiple availability zones behind an application load balancer. The load balancer is in public subnet, EC2 instance or in private subnet and must not accessible from internet. EC2 instance must call external services on the internet. If one AZ becomes unavailable, the remaining EC2 instance must still be able to call the external services. What is the answer?
D.
Option A, sir.
So direct inbound traffic means you need to manually add an entry via internet gateway to your NAT and all. So that's not really required. Once you deploy NAT, it automatically picks. It automatically communicates with internet gateway, so that's not really required. So, so first, are you going to create a NAT instance or NAT gateway? Which one is more reliable? NAT gateway. So eliminate C as the answer. So are you going to configure internet gateway to provide internet to private subnet instances? So eliminate B also. Now A and D. Okay, create a NAT gateway attached to the VPC. Can we attach NAT gateway to a VPC? Can we attach NAT gateway to a VPC or availability zone? Availability zone is nothing but, like, a subnet. Subnet is nothing but an availability zone. So for root table, we are going to do what root table will contain? Root table will contain entire VPC or subnets. Subnets. So create a NAT gateway, update the root table for each private subnet to access internet via NAT. So this internet bound may confuse you. That AWS will do automatically. You don't need to do that. So you just add NAT gateway for each availability zone. If one availability zone goes down also, we should sustain. Why we are asking it to create it in multiple? He is clearly saying if one AZ becomes unavailable. If one AZ becomes unavailable, so if you have multiple, I mentioned this statement also today. If one goes down, another one will provide internet to private subnet instances. So go with the D as the answer here. Okay. B will make those as a private subnets as a public subnets, not suggestible one. NAT instance is not recommended to use. And NAT gateway we cannot attach to VPC. Okay. So you can eliminate wrong answers also and you can get the right answer. Okay. This we will discuss later. Pretty straightforward question. A, right? IPv6, private subnet.
Option A, sir.
Egress only, internet gateway. Just two more questions.
VPC endpoints.
VPC endpoints.
See endpoint? Yes. So he's saying private subnet instance without internet and he want to access S3. Okay. So endpoints. We can go with the endpoints. Last question. So they have an application inside an EC2 instance. Okay, that is accessing S3 via internet. So they don't want to route any traffic via internet. They want to eliminate that internet access, but application need to work as expected. Same question, but is elaborating with a scenario. Same question as the previous one. What is the answer?
Option
B. Okay, yeah.
VPC endpoints on Amazon S3.
Yes. Option B is the answer. Same question as the previous one. There is, but here he is giving a scenario, he is elaborating more just to confuse you. There it is bit straightforward. Okay. So these are some questions on our VPC And these some architectures, I'll share that VPC diagram, okay? So generally in organization, we are going to prepare such type of diagrams. Let me quickly show you one.
Recording stopped.
I stopped the recording. Come on. File, device. Yeah, this is one architectural diagram I prepared. So you also need to slowly start using this tool. Okay, so you may need to prepare such type of diagrams later. So the mechanism here, hub and spoke model, whatever the EC2 instance we have in different account, if it is trying to access any domain, so the DNS and domain and everything is working in on-premise. So the request from EC2 instance, it comes to root 53. The root 53 will forward it to central networking account. So there we are using endpoints. This is a symbol of endpoints. So that endpoint is enabling the routing the traffic to transit gateway. This symbol is a direct connect. You remember direct connect? It established connectivity between on-premise to AWS with dedicated line. So it's there in organization. So we are accessing resources here. Okay, so this is one diagram. So there you can see VPC and its components and all.
Avinash, we cannot
So
able to
we
see
couldn't
the
see
diagram.
the diagram.
Oh, okay. Sorry. Okay, able to view now?
Yes.
Yeah, this is one diagram. So this is a spoke account, this is hub account. Whatever instance we have here, if it is trying to access any resource from on-premise and all, it should able to access, or vice versa. Whatever server we have in on-premise, it should able to connect to this EC2. So in between we have direct connect. Okay, so transit gateway, this route 53, this is a VPC. Within that VPC, we have multiple subnets. You see here, this is subnet 1, this is subnet 2. So we segregated. So the diagram actually shows entire flow, how things are working and all. So you might need to prepare similar diagrams. So get started with VPC first. VPC, multiple public subnets, multiple private subnets. Start with that and slowly progress into complex ones. Okay. So I have given a task, right? In our last session, try to prepare a diagram for that. So the task, this time the task is pretty straightforward, guys. Practice entire VPC except NAT gateway. So for this, alternative is use NAT instance if you don't want to get charged. Okay. Yeah. So VPC is a primary component, as I mentioned multiple times. All right. So yeah, that's it for today's session. See you again on Monday. Have a nice weekend, guys. Thank you.